is element number 16 with a mass of 32. It is a yellow solid at room temperature. It is a non-metal, having all the properties of non-metals. For example, it's an electrical insulator. Sulfur is a very important raw material, and there are many sources of sulfur. It can be extracted in the solid elemental form. It's a yellow solid from under the ground in mines. It is produced as a byproduct of refining petroleum or crude oil and natural gas. You get some sulfur out from there. It's an impurity that is removed. And it can be extracted from ores which contain sulfide. So you can get metal sulfides. Why is it important? Sulfur has many uses in industry. For example, it's added to rubber for tires in a process called vulcanizing. Makes the rubber more flexible and sturdy. It can be used to make sulfur dioxide by burning sulfur in air, and sulfur dioxide itself is used to bleach paper and to kill bacteria in food and drinks. The main use for sulfur, however, is in the manufacture of sulfuric acid. Sulfuric acid, H2SO4, is a very strong acid. If you've watched my video on acids, you'll know what strong means. It means that it fully ionizes into hydrogen ions in water. Sulfuric acid is a particularly powerful acid, as it's what we call a dibasic acid. Dibasic means that each molecule of the acid will produce two hydrogen ions. If you compare that to something like hydrochloric acid or nitric acid, they will only produce one hydrogen ion. So each sulfuric acid will produce double the hydrogen ions. So it's a particularly powerful acid. As an acid, it reacts in the same way as other acids. So it produces hydrogen when it's added to reactive metals, carbon dioxide when it reacts with carbonates, it neutralizes bases, and so on. So it acts the same way as other acids. It is a very corrosive substance, even when you compare it with similar acids such as hydrochloric acid. Concentrated sulfuric acid is also a very powerful dehydrating agent. What that means is it removes water from things. That's a very exothermic reaction, and concentrated sulfuric acid should never have water added directly into it. It'll go like that, it'll explode. However, if you want to remove the water from something, for example, you're trying to produce a dry sample of a gas, you can pass it through concentrated sulfuric acid, and that will remove the water vapor. That's a very useful tip for paper 6. You might be asked about that. Concentrated sulfuric acid will also remove water from things where the water is chemically bonded to the structure. For example, sugar has the formula C6H12O6. You can probably see that there is hydrogen and oxygen in there in a 2-to-1 ratio. That can be turned into water, H2O. If you add concentrated sulfuric acid to the sugar, it will remove that water and it will become carbon in a quite spectacular reaction. I'll put a link to somebody else's video of that reaction in the description of this video so you can see what I mean. I said before that sulfuric acid is an important chemical. Why is that? Well, it's used in a variety of things. It's used in car batteries. It's used as a very common catalyst in many organic reactions, for example, making esters. It is also used to make cleaning products, soaps, etc., etc., and it's also used as a raw material for many different industrial chemical reactions. So it's very useful. It's got a lot of different uses. So how is sulfuric acid manufactured? Well, first off, if you haven't already seen it, go and watch my video on equilibrium. I'll be referring to some concepts from that in this video without taking time to explain them, as this is an equilibrium reaction. Sulfuric acid is made using a process called the contact process. The contact process consists of 3 steps. The first step is the oxidation of sulfur. What that means is taking solid elemental sulfur and burning it in air to produce sulfur dioxide. This step goes to completion. It is not an equilibrium. The sulfur dioxide which is produced is a gas. It's also quite a nasty environmental pollutant, so care must be taken not to release it into the atmosphere. That's step 1. Step 2 is the reversible reaction. The sulfur dioxide from step 1 is added to more oxygen in order to produce sulfur trioxide. This requires a catalyst of vanadium pentoxide, V2O5. In an equilibrium like this, specific conditions must be used in order to increase the yield. Again, go back and take a look at the video on equilibrium and also on the video on the Haber process for more details. The conditions for the contact process and the reason for choosing each of them are as follows. A temperature of 450 degrees Celsius is used. The forward reaction here is exothermic. So that means a high temperature will shift the equilibrium to the left. That will decrease the yield. That's not what we want. But a low temperature will increase the yield but will reduce the rate of reaction. So 450 degrees Celsius is a compromise between the yield and the rate of reaction, just like in the Haber process. The pressure that's used is only 2 atmospheres. Not a very high pressure at all, higher than atmospheric pressure, but not very, very high. Much lower than the Haber process, for example. Increasing the pressure will move the position of the equilibrium to the right. There are fewer gas molecules on the right. That will therefore increase the yield. But the position of the equilibrium at the lower pressures is already very far to the right. At 2 atmospheres, the yield is around 98%. So it isn't really worth the extra money to increase the yield just that little bit more. As mentioned before, the catalyst is vanadium pentoxide. It has no effect on the position of equilibrium, but it increases the rate of both the forward and backwards reactions. So that's step 2. Once that sulfur trioxide is produced, in step 3, it gets added to a solution of concentrated sulfuric acid. When it is added to concentrated sulfuric acid, the sulfur trioxide will react to produce a thick, sticky liquid called oleum. Oleum has the formula H2SO7. Oleum can then be added to water to produce the sulfuric acid, just like this. So H2SO4 is sulfuric acid. So why do we bother with that step? Why don't we just add water straight away and produce sulfuric acid? Well, the reason is that the oleum is made first is that, firstly, safety. If you add sulfur trioxide to water, it will produce a spray or a mist of concentrated sulfuric acid. Very dangerous. Secondly, cost. Oleum is, by atom, much more concentrated than sulfuric acid is. So that means you can ship around the oleum to wherever it needs to go and then dilute it with water once it gets on site. That will reduce the cost of shipping. So that is sulfuric acid and the contact process. Compare it with the Haber process. There's some similarities and some differences. It is the second step of the contact process is a reversible reaction and there is an equilibrium, so you need to know the conditions and why they're chosen. Thanks for watching.